Ask a simple question about our place in the solar system, and you might get a seemingly obvious answer. What exactly does the Earth get from the sun? The immediate response is usually energy, but that is entirely wrong. Every single day, the Earth radiates the exact same amount of energy back out into the freezing vacuum of space. This strict balance comes down to the first law of thermodynamics. Energy is a constant. It can take on different forms, but it can never be created or destroyed. This presents a glaring paradox. If we return every ounce of energy we receive from the sun, what exactly is being consumed to power the hurricane systems, the mechanical engines, and biological life on Earth? The answer requires confronting one of the most misunderstood concepts in physics. It is a statistical ghost dictating the physical direction of time itself. Once you realize we are entirely wrong about what the sun actually provides, you start to understand exactly why every structure in the universe is doomed to eventually wind down and stop working. To trace this back, we have to look to a teenager in 19th century France. Sadi Carnot watched his country fall to advancing foreign armies and decided to restore its military might by designing a perfectly efficient steam engine. He imagined an ideal, frictionless machine. Inside a chamber, air is heated by a hot metal bar, expanding to push a piston upward and turn a flywheel. But Carnot realized a devastating flaw in his perfect math. To bring the piston back down and repeat the cycle, that trapped heat had to be dumped into a cold bar. You always have to pay a toll just to reset the system. Lord Kelvin read Carnot's work and realized that reaching 100% efficiency would require an impossible condition: a cold side at absolute zero, where all molecular motion completely stops. In the real world, things are much worse. Physical engines experience friction. Heat leaks out of the cylinder walls and bleeds into the surrounding air. The energy disperses outward into the environment. The total amount of energy in the universe remains the same, but the moment it spreads out into those surrounding materials, it becomes permanently useless. A perfectly efficient machine is a mathematical impossibility. A few decades later, the German physicist Rudolf Clausius observed this phenomenon of spreading energy and finally gave it a name: entropy. Entropy is often mislabeled simply as disorder. In strict physical terms, it is the intrinsic tendency of energy to disperse, spreading out until it is no longer available to do work. To understand why energy inevitably behaves this way, Ludwig Boltzmann took Clausius's concept down to the microscopic level of individual vibrating atoms. He realized that heat flowing backward from a cold object to a hot one isn't blocked by a physical force. It is just mathematically improbable. There are quintillions of ways for energy to spread out randomly, and only a tiny handful of ways for it to stay neatly organized. Entropy is nothing more than the cold math of probability. Physical systems naturally shift from highly concentrated, unlikely states into messy, highly probable ones, simply because there are astronomically more ways to be messy. This statistical rule solves the Earth-Sun paradox. If entropy demands that energy is always spreading out, we have to look closely at what is arriving from space. The sun provides a steady, hyper-concentrated stream of low-entropy energy. It arrives entirely bundled up in the form of high-energy photons. Plants capture these highly organized bundles to build complex sugars. Animals eat those plants, using the concentrated energy to assemble complex bodies and move around. Life itself acts as a highly efficient machine for processing low entropy. With every step in that food chain, the energy disperses a little more. Earth takes that useful energy, burns through it, and radiates the exact same total amount back into the void. Except now it is fractured into 20 times as many low-energy, useless photons. We survive because we sit directly in the path of a constant low-entropy source, and we have the vast, freezing emptiness of space to absorb our high-entropy waste. If the total entropy of the universe is constantly increasing and spreading out, that forces a massive cosmic question. Where did the initial, pristine, low-entropy state come from? Tracing the timeline backwards leads to the Big Bang. Physicists call this the past hypothesis. For the universe to unfold as it has, the initial conditions immediately following the Big Bang had to possess an unimaginably low entropy. In an early universe where matter was spread out uniformly, gravity was the deciding factor. It violently clumped that dust together, creating massive pockets of potential energy waiting to be spent. But the vast majority of the universe's entropy isn't found in those glowing stars or planetary systems. As Stephen Hawking proved, almost all of it is locked away entirely within the surface area of black holes. Every galaxy forming, every asteroid impact, and every biological evolution that has ever occurred is simply the universe slowly burning through the initial, concentrated budget of low entropy it started with. Eventually, that budget will run out. Far in the distant future, the universe will reach a state of maximum entropy, known as the heat death. All energy will be completely dispersed, and the physical arrow of time will effectively disappear. A universe completely dead and dispersed sounds bleak, but maximum entropy is surprisingly similar to the absolute low entropy state of the Big Bang. Both extremes are completely featureless, uniform, and lacking in structure. The reality is much closer to a cup of dark tea. Hold it still and it is uniform, but pour in a splash of milk, and as the two liquids mix, intricate swirling fractal patterns briefly emerge before settling back into a flat, uniform color. It is exclusively during this chaotic, middle transition phase that beautiful, intricate, and complex structures are mathematically permitted to form. The relentless increase of entropy guarantees that the cosmos will eventually settle into stillness. But this exact process of energy spreading out is the sole mechanism that allows life, consciousness, and a fascinating universe to exist right now.